Hello student, welcome back. This is Bharat Kuman from Mechanical Engineering Department. So student, today we are going to discuss about a Carnot engine. In this topic we are going to discuss principle, PV diagram and TS diagram. So without a wasting of time, let's start today's session. Carnot engine principle. Carnot principles are just for cylindrical devices such as heat engine, which state that the effectiveness of an irreversible heat engine is always less than the efficiency of a reversible one functioning between similar two reservoirs. The effectiveness of all reversible heat engine working between similar two reservoirs is equal. So student, it is nothing but the principle of Carnot engine. Now student, let's discuss about a PV diagram of Carnot cycle. The Carnot cycle in this heat engine consists of two isentropic and two isothermal process. Student, here we can see in the diagram there is a two isentropic process and two isothermal process. Let's start with process AB. It is nothing but the reversible isothermal compression. Student, here we can see in the diagram there is a process AB. It represents reversible isothermal compression. After gas reaches the low temperature, some external force is applied on the engine in order that gas can be compressed. Since the temperature remains constant, no change of internal energy of gas occurs if we assume that gas is an ideal gas. Student, knowing from the first law of thermodynamics, we obtain a conclusion that heat must be transferred from engine to low temperature reservoir. Now student, let's see process BC. Here we can see in the diagram it is represent a reversible adiabatic compression, otherwise we can say isentropic compression. Student, this process is known as isentropic, where the engine is perfect insulated so that no heat is lost and absorbed. Gas continues being compressed slowly until the temperature rises from low temperature to high temperature. Now student, process CD. Here we can see in the diagram it is reversible isothermal expansion. During this process, heat is absorbed. Now gas expands reversibly at the constant temperature. Now student, last process, it represents DA. Here we can see in the diagram, it is reversible adiabatic expansion. Otherwise, we can say that isentropic expansion. Student, during this process, the engine is perfect insulated so that no heat is lost and absorbed. Gas continues expanding slowly until the temperature drops from high temperature to low temperature. Now student, let's understand this PV diagram in briefly. Here previously we just discussed about a process AB. It is isothermal compression. During this process, gas compressed, heat given out and entropy falls at constant temperature. Now student, let's see process BC. It is adiabatic compression. During this process, gas compressed, but no heat added or lost. Constant entropy and temperature rises. Now, process CD. It's isothermal expansion. Heat added, entropy increase. Gas expand, constant temperature. Now process DA. Gas expands, no heat added or lost, constant entropy and temperature falls. It is also said that adiabatic expansion. So student, in the PV diagram, we just seen two isothermal process and two adiabatic process. Now student, let's discuss about a temperature versus entropy diagram. It is also known as TS diagram. Okay student, now start with process AB. It is nothing but the compression process where work done on gas. During this process, heat extract but constant temperature. Process BC, compression but no heat added or lost, even no work done. Student, here we can see in the diagram. Process CD, expansion process where work done by gas, where heat added but at constant temperature. Now process DA, it is a expansion process. No heat added or lost, even no work done. So student, here we just discussed about a PV and TS diagram. Now student, according to the Carnot efficiency, we can also draw the following conclusion. First one, the Carnot efficiency only depends on the highest and lowest temperature. Second one, if we want to increase the Carnot efficiency, we can increase the highest temperature or reduce the lower temperature. Third one, the efficiency of a Carnot heat engine is always smaller than 1. Only when highest temperature is infinite or lowest temperature is 0 could thermal efficiency is 1. But both methods are impossible in the practice. Fourth one, for high temperature is equal to low temperature, we have a efficiency is equal to 0. That means if we only one reservoir, system is not able to undergo a cyclic process. And of course, no work can be done. So student, kindly attempt this mind twisted question and find a link in a description box. Student, we just finished here today's session. In upcoming video lecture, we will discuss about some more interesting topic. Till keep learning, keep growing. Thank you.